This is an example of how to download current version of Mach 3 and install the program. Here you can see we're on the front web page of the Art of CNC website, www.artofcnc.ca. We select the downloads page, and there are usually several files available for download. The one that we're interested in will of course be under the Mach 3 heading, and will usually be in this area here. The Mach 3 beta versions will disappear very shortly, probably by the time you listen to this video, and you will see Mach 3 release 1.0 or further on up the series. We simply click here to download. We want to save it, and I usually save it to my desktop just for ease of access. I already have one. You won't get this warning, hopefully. And now we're downloading. Once the program downloads, it's 7.5 megabytes at the moment, so it does take a little while to download. But once it downloads, warning goes away and you can now close the screen. Here's our version that we just downloaded. We'll run it. We'll go through the normal warnings. You can see that you can just push next. It's smart to install in the default folder of C Mach 3. This is for support purposes. If you're an expert and you can deal with it being in your program folders, please feel free to do so. If you have already installed a version of Mach 3, you'll get a warning telling you that you're going to upgrade the installation. There's no problem with that. You're free to upgrade at any time, but before you upgrade, you should give some thought to backing up your XML files, which will be covered under a different video. Because they contain all of your settings. You may also want to back up your tool tables and any special macros that you might have created. A solution to that is to create your own profile, and we'll go over that in another video as well. So at the moment, we're just going to do standard installation. The program is now installing all the files. You won't get this error. If you create a special profile and change your turn icon to a read-only file, you'll get this. Again, you don't need to worry about it unless you're quite advanced in Mach 3, and you'll be used to seeing that error in any event. We've now registered the OCXs. The program will now warn us that it wishes to install the driver. At the moment, it's unzipping all the files necessary. There are over 100 megabytes of files in Mach 3 at the moment, so it can take a little while. Now it's asking us if we want to load the Mach 3 driver. Should we say no, the program will install as a simulator. You will get no motor output, but you will be able to generate G-code and see the effect of running a file as if you had a machine installed. This is a handy option for those who wish to have Mach 3 running on a laptop or some system that is not running a machine, and they wish to use it only as a simulator. This will not load the printer port driver and doesn't stress the system at all if you uncheck that box. If, however, like me, you're going to run a machine, then you want to leave that checked and load the driver. Now we've installed the driver and we're getting a very important warning. You should reboot before running program again. This is only necessary if you have never installed a Mach series program on this particular computer. If you've installed Mach 1, Mach 2, or Mach 3 before, you do not need to reboot. If you have never installed any of the Machs, you must reboot. Many people contact me with computer crashing problems which were caused because they ignored this warning. I realize some programs will allow you to ignore that warning, but Mach 3 is doing some very special things to your system, and the reboot is necessary. So take it from me, reboot. Now we're going to go look at our installation under Mach 3. And you can see that there's an icon in your Mach 3 folder called Driver Test. This is a good way to test your system to see how your computer responds to Mach 3. Here we're going to take over the system in 3 seconds with the driver. One of two things will happen. There's one of them. Preparation successful. You may have rebooted. Take over in 1 second. Now, this is a good waveform for Mach 3. In fact, it's pretty exceptional. At approximately 38 microseconds between interrupts, and we have a flat line. These little jittery lines you see are slight variations or microsecond jitter in the pulse stream. This won't affect your motor typically. Those are very small variations, and this waveform is considered a very good one. If your computer crashed when you ran this program, then you have a problem. Your computer, if it went to blue screen of death, does not like the driver which is installed. If that should happen to you, there is a file called specialdriver.dat, which should be in this system somewhere. I'm going to arrange the icons by name so we can find it easier. There it is right there, specialdriver.bat. If you run that file, it will switch a new driver into the system. So after your computer has crashed on you, reboot it up, come back to this folder and double-click this icon. It will very quickly open a box which switches to a special driver. When that occurs, run the driver test again and you should not crash and you should get a waveform. If you get a waveform which is terrible, one which is not a straight line like this one gives you, but large spikes all over the system, or you may find you've got noise going up to this level and just periodically messing up your waveform, then you need to run a file called optimization.txt. This is a text file which has several steps in it which can help you to remove processes in your computer that Mach3 is having a problem with. There is several things in the list, and you can either contact me for the list, download it from the website shortly, or get it from the Yahoo support group. Another important point is the Yahoo support group, and you would be well advised to go to this link here to the Yahoo support group. There are a lot of people there, and they can really help with problems that you might have should you not be able to reach me in time. There is a files section which has several files in it that can help you through various problems, and there's a message list with literally thousands of messages that you can search for problems that people have had. And that's it. With that having been done, you are installed. You can now run Mach3 Mil, and it should start up the program, and you're ready to configure the program. There will be a separate video that you can watch on configuring the program and getting it set to do the things that you need it to do. Thanks for listening. Goodbye. We're going to take a look at configuring the Mach3 system now. You've just started up your program. It probably looks exactly like this screen with the reset button flashing, telling you that you have not reset the system. One of the first things that we're going to do is configure it. So we'll select the native units. You'll see you get a warning telling you not to use this selection to change between metric and English G-code. If you are a metric user primarily, set up your machine for metric. If you're a English user generally, then set it up for inches. You will never use this setting again. Once you set it, leave it alone and never change it. There are other ways to switch between English and metric for your G-code programs. If you change this setting, once you've set it, you'll have to retune your entire system. So pick a common use of your system and use that. I'm going to select millimeters because that is my normal use of my system. And we hit OK. Next step in configuration, in a general configuration, is ports and pins. You can see here that we have port number 378. That is a standard printer port address for port 1, and we have it turned on. Port 2 is turned off at the moment, and you probably won't use a second port. If you do, however, the addresses of the ports can be entered here and you can turn them on. If you use a port 2, you can also use pins 2 to 9 of that port as input signals in case you'd like to get more access to more inputs. Kernel speed should always be left on 25 kilohertz unless you have a system which requires excessive speed. 25 kilohertz is the least intrusive mode to your system, and it's highly recommended for all new users, irregardless of how much speed you need, to use 25 kilohertz. Now, you may have a system which does not have an address of 378 for your printer port. Most people do. To find the address of your printer port, you simply go to your control panel, system icon, select hardware, then device manager, and you'll see that your Under ports, your printer ports are listed. LPT1 is my first port. So if I do a properties of it and select resources, you can see that the address in the I/O range, the first number is 378. This is the number that you enter in that box. If you had a second printer port, such as I do here, with a Lavasoft parallel PCI card, LPT3, if I check its resources, you'll see that it is B000. So if we exit out of here and go back, I could turn on port number 2 and enter B000. You do not have to enter the 0x portion. The program will do that for you. And we hit apply. Over here on this side, you do have the choice of setting up a Mach3 or a Mach3. If you do this, you don't need to set the pinouts for the motors. But these are only applicable to the Mach series. Leave them off otherwise. If you have a Sureline, select the half pulse mode. This stretches the mode specifically for Sureline products. Most do not need it, and don't use it unless you have a Sureline. For Modbus input-output support and event-driven serial control, leave them off until you've hit a state of expertise in using Mach3. They're not required unless you're using PLCs and other serial control equipment, and they will affect your system slightly in performance if you use them when you don't need them. Then we go to the motor outputs. In motor outputs, you should have a checkbox turning on each one of the motors you intend to use. You do not need a checkbox for the spindle unless you are going to use the step and direction or PWM options to drive your spindle. If you're driving a spindle that's simply controlled with a relay, you do not need to have spindle turned on. Hit apply whenever you make a change. Here you can see we have the step pin and direction pin of the x-axis. This information, which pins you enter in these boxes, should be an information provided to you by your CNC manufacturer. Whoever has built your table should have sent you a technical document telling you which pin controls which axis. In this case, you can see I've got the port selected is 1 for all settings. The step port is 1, the step pin is 2. So port 1, pin 2 is x-axis. Port 1, pin 3 is the direction control for the x-axis. When it comes to the settings for low active or not low active for a particular axis, you're better off leaving them unchecked until such time as you determine you have a problem. Many systems will run irregardless of these checkboxes. These are only necessary for some systems which are a little pickier as to whether the voltage is going high or going low at a time when the commands are being sent out. So all you have to set here is turn on your motors, set your pinouts, and then hit apply to store the results. Under input signals, for a basic setup, when we're starting up, you don't want things interfering, so turn them all off, with the exception of e-stop, which you cannot turn off. E-stop you can set to port 0 if you don't want it to affect you. Otherwise, set it to port 1, pin 17 would be fairly typical. Pin 15 would be fairly typical, and will do the job for you. You can see that the active low is checked off. Therefore, a high signal is what is going to trigger an e-stop. At this point, you can pretty much stop using this configuration. Your primary task here in this setup is to get your motors running. So all you need is an e-stop signal, the proper motors turned on with the proper pins, and your ports set up correctly. Beyond that, you don't need anything to get your motors to run, so let's hit OK and let things go. Now you can see that my reset button is flashing. If I push reset, it's still flashing, and I get a message, external e-stop requested. This is because of a change that we just made. Under ports and pins, input signals, you can see that the e-stop signal is checked so that it is an active high. If you don't connect a wire to a printer port pin, it will be high. Since we've selected active high, we're seeing a permanent e-stop condition coming into my printer port because I don't have a machine hooked up here. So by selecting this as active low and hitting apply, the e-stop signal will disappear, and you can see that although it's flashing, pressing it will reset it. You can always check to see if a signal is interfering with you by going to the diagnostics page, and if this emergency input was blinking, it means that the active low setting is set incorrectly and it is seeing an emergency stop. So now we have set up our motors and we want to move down. The next step that you need to do to get basic movement is motor tuning. So we'll go to the motor tuning stage. The first thing that's important is how many steps per unit it takes to move your table. As I said earlier, we set ourselves up for this machine in millimeters, so the steps per here refers to millimeters. Steps per millimeter, I have mine set to 2,000. If you don't know your steps per millimeter, we can calculate it out pretty easily, but use 2,000 as a start. Once you've set a steps per millimeter of 2,000, you need to test to see what acceleration and what velocity you're going to use. I should mention that before you start anything on this tab, hit the axis button that you're interested in. It brings up the stored results of that axis. So here we have the x-axis. We're going to set this as an example for the user to 1,800 steps per millimeter. Once we change, anytime we change this steps per unit, we must touch the velocity and touch the acceleration sliders so that the system will recalculate its current settings based on its steps per unit. At this point, we can slide our velocity slider up and down to select different speeds. The speed is listed over here on the side in inches per minute or millimeters per minute, whichever you have selected. At the moment, mine says velocity in inches per minute, which is wrong. It is actually millimeters per minute, and that's a bug that I will have to add to my list for repair. If we slide to a particular speed and we want to know whether or not that speed is good, we can hit the up and down arrows on our keyboard right now while we're in this window. You can't see my motors moving here at the moment, but they are moving when I touch my up and down arrow keys. You want to adjust for a maximum speed, which is your G0 speed, which you're happy with. If you slide this slider to a particular speed, use your up and down arrows, and the motor sounds good, then that's a good velocity. You then want to grab your acceleration and move it up or down to select an acceleration that causes your motor to move without jerking. If it takes off smoothly and stops smoothly when we use the up and down arrow keys on the keyboard, then that's a good speed for your motor. Whenever you've done those few steps, hit Save Axis Settings to store them in memory. Then you could move on to the next axis, in this case the y-axis, the z, the a. The only buttons which will be lit are the buttons that you turned on in the ports and pins. If none of your buttons are lit, it means that you didn't select these axes in the setup of the ports and pins. Once all your speeds are set, you can exit this screen. The only other thing that I'll mention on this screen is step pulse and direction pulse width. These are the widths of your step and direction pulses. They're actually additions to the width. Step and direction pulses are typically approximately 1 to 2 microseconds long by default, and that's long enough for the vast majority of systems out there. If for whatever reason you find that your motors are not moving when you're using your up and down arrow keys, or they sound bad, you can use these numbers to increase between 0 and 5 the step pulse width or the direction pulse width. The only time you'll change a direction pulse width is if you find that you're losing one step each time you change direction. For 99% of users, you will never change this above 0. For 90% of users, you will never increase the step pulse above 0. Some controllers, however, do require up to 5 microseconds of additional step pulse width because the optocouplers in the drivers are a little slow, and this gives those optocouplers a longer time to adjust. So at this point, you should have basic movement. If you hit OK and exit out of that dialog, using the arrow keys on your computer now, you should see your axes jogging around. There are things that could stop that from happening, however. Pressing the Tab key on your keyboard will bring out the Jog Control tab. you'll see here a number, slow jog rate. It is currently set to 50%. If on your system it is set to 0%, then you'll get no movement. Typically this is set to 50%. And what that does is give you two speeds of jog. Just hitting the arrow keys on your keyboard, you can see I've got a speed of approximately 10 millimeters per second being fed. If I press the shift key at the same time, I now go to fast jog, and I have 20, which is twice the slow jog. In other words, slow jog is 50% of the maximum rate, and you get the maximum rate by pressing shift. Notice when I press the shift key that the fast jog indicator lights up. Otherwise, you're on normal speed. The rest of the controls on this page you can pretty much ignore until you get more advanced. We have settings for the slow jog rate. You can increase it. You have buttons which will allow you to jog simply by pressing the button on the screen here. When it comes to the MPG modes and shuttle modes, leave them off for now unless you get to the point where you're hooking up an MPG. An MPG is a manual pulse generator. It's an encoder which you can rotate and jog with the rotation of the encoder. It can also do other sharp features like shuttle mode, which allows you to run a program while rotating the wheel. The program actually runs at the speed that you rotate your MPG. You'll notice when I selected shuttle mode, our jog mode went over to MPG mode. Turning off jog mode, and we'll go back to the normal jog. So if you look at this screen, the second LED here should be lit, indicating that you're in normal keyboard jog mode, and you should have a jog speed at least around, well, let's put it this way, a jog speed above 5%, and you should see movement. Hitting the tab key will make that jog screen leave the screen. So at this point in the program, I can now jog, my motors are moving, and if you've tuned them properly, you should now have some pretty good movement with them. If you want to do a test to see how your system can respond, we can now just load a G-code file. If you select the Mach3 folder on your system, there's a G-code folder, and once you select it, there are some test programs in there. This one is called Roadrunner, and will allow you to cut a test cut of a Roadrunner. When I hit cycle start to start the program will begin to move, and you can see that my speeds and feeds are probably not adjusted appropriately for this particular program, but eventually you'll see a green line trace out the path of the Roadrunner, and your motors should now be feeding themselves at that speed in that area. That's it for a general setup of Mach 3. For the beginning user getting their motors running, that should be all it takes. And that's it. Thanks for listening.